Hi there, this is Architect David. Welcome to Arkida, where you can learn anything and everything about construction. This video introduces you to plumbing. It will give you a basic understanding of what plumbing is all about. Now, the general properties of water, obviously, the first is liquid. We all know that it is a liquid. Water is a liquid. It has perfect fluidity. It can travel with no or less resistance in 90-degree angled pipes. The surface tension or the skin is the property of the surface of a liquid that allows it to resist an external force due to the cohesive nature of its molecules that is directly related to the actual perfect fluidity of water. Freezing point. It starts to solidify as it nears 0 degrees Celsius. Likewise, water turns to liquid as it goes farther from 0 degrees. Boiling point. The water molecules agitate and starts boiling at 100 degrees Celsius. Now, for definition purposes, supplying water in a desired quantity or in the desired quantities at the point of usage, meaning to say, the point of usage is your faucet. How to supply water to that faucet? It's now commonly referred to as plumbing or clean water plumbing. Removing water and waterborne waste from fixtures, let's say water closets, equipments, and areas is now commonly referred to as the drainage. Now, the tips to consider when designing plumbing. If you are to design a clean water line, the inlet pipe size should be bigger than the outlet pipe size, meaning to say, the supply pipe should be bigger than the ones at the faucet end. While in the sanitary sewage water line, the supply pipe, which is actually, let's say, the water closet, should be smaller than the outlet pipe, which is the pipe going to your septic tank. Remember, the trick here, or the word to try to remember, is gravity. So normal water pressure is generally between 40 and 60 psi. Most homeowners prefer something right in the middle at around 50 psi, or pounds per square inch. Now, for the history of plumbing, it started from the word plumbum, which is a Latin word meaning the art of working with lead, because before, during the Greek areas or the Greek times, they started using lead as the pipes. Now, for the hydrologic cycle, meaning to say, the water, if you look at the picture here, the water evaporates. It goes to the clouds. Then it rains. It goes to the oceans or rivers. Then you already have your own water supply. You use it. Then it will again evaporate and it will go to the clouds. It will rain and so on and so forth. It is just your own circle. Now, many of you have been dependent on your utility service or water utility services. Where do they get the water? One source is the river or stream. Another source is the groundwater. This is where you use deep well pumps. Groundwater is the water found underground in the cracks and spaces in soil, sand, and rock. It is stored in and moves slowly through geologic formations of soil, sand, and rocks called aquifers. Now, as early back as the Roman times, they have invented what is now called as aqueducts or viaducts or water bridges. These are bridges constructed to convey water across gaps such as valley or ravines. Now again, gravity, as I said, try to remember that word, gravity and the natural slope of the land allowed aqueducts to channel water from a fresh water source to the city. Now, in certain parts of the world, they rely on frozen water, which is actually ice. You wait for it to thaw and use the thawed water as your water source. Another source of water is what is called as reclaimed water. Meaning to say, you take the raw sewage, as seen on the picture here, You keep on filtering it, you get a plant effluent. Then the final product is what is called as non-potable reclaimed water. It is being pumped back to the houses or to the buildings for toilet purposes, meaning to say that is you have a pipe that will supply water or reclaimed water that will supply it to your toilets. Again, another source of water is what is called as desalinated water. You get the seawater, you start filtering it, you take out the salty part of it using ultrafiltration and reverse osmosis. Then what comes out is now what is called potable water. Now, there are two minimum requirements for civilization. Actually, this is for the whole society. One is to have a sewage system to carry away wastewater. When we say wastewater, these are the waters which came from your kitchen, came from your toilet. Okay? So, the second minimum requirement is a consistent and reliable water supply system to provide water for drinking, bathing, and irrigation. Now, a water supply system consists of several components. This includes the source of water, which I've just discussed, a system to extract and transport water, a facility to treat the water so as to remove the impurities and make it potable before use, and a water storage system that holds excess water and provides for periods of low water supply or even outflows during periods of variable usage. Now for water storage system, we have what is called a dam. This is a water reservoir which provides water to the city. The next one is called a floodgate. The reason why it's called a floodgate is because if the dam reservoir levels are going beyond the maximum limit, they will have to open the floodgates to release out certain portions of the water to be given to the city. The next one is called a cistern. This is either underground or above ground, and basically its use is to collect rainwater. Now for a rainwater harvesting system, as you can see in the picture, you have the rainwater from the runoff to the gutter, down to the piping. You may add a filtration system or not. Now the main tank is, as I said, it's called a cistern. Now you will pump it up to the either watering for irrigation, car washing, toilet flushing, and clothes washing. It is not potable, or it is a non-potable type of water. The overflow of this is going to be thrown back to the land or to groundwater. Another type of storage system is what is called as a pressure tank. The pressure tank in a water well system creates water pressure by using compressed air to bear down on the water. Because of this pressure, when the valve is open, water is pushed out of the tank through the pipes in your home. When the water in the pressure tank drops below the required amount, a pressure switch is activated, turning on the pump. The pump then refills the pressure tank. The combination of pressure tank, pressure switch, and the pump is what allows water to flow through your home. One of the variations of a pressure tank is the air over water pressure tank. As you can see in the picture down below, you have the dry side of the tank and the wet side of the tank. It has an air fill valve. So, as the water is being pumped out, the air pressure decreases. Then as you fill up the tank, the air pressure now increases. It is up to you to know or to decide which water pressure would you want by adding more air to the air fill valve. Another type of pressure tank is called the diaphragm pressure tank. It consists of two separate chambers, one for the compressed air and another for water. Using the previous slide's principle, you again fill it up with water, Then you have a rubber diaphragm, which pushes the water down once the air is compressed above it. Again, there is an air valve which can be serviced without removing or replacing the entire tank. Another variation is what is called as the bladder pressure tank. This type of tank is used for bigger water storage. If you look at the text down below which says waterlogged tank, it means a waterlogged pressure tank is caused by the confined space within the tank having an improper ratio of water to air. Too much water, not enough air. Given the physical characteristics of water, this condition causes the pressure to fluctuate rapidly and the well pump to go on and off too much. So meaning to say, if you have a pump that is turning on and off erratically, your tank is now what is called as a waterlogged tank. To fix this situation, you turn off the pump, then you take out the full water of your tank. You just throw it out. Once it is now out, you have a tank that is well balanced again. You close off the valve down below where you are throwing the water, then turn the pump on again. This variation is called the overhead gravity tank. This does not have any pressure or any air pressure to push it to the faucets or to the supply. Meaning to say, you have a water supply, you pump it up to these tanks. Then when you need the water, you will rely on gravity to push the water down to its source. Now, to discuss the various terms in plumbing, for you to be able to understand what it means, you have first of all what is called as a cut-in and cut-out. All pressure switches, these are switches which are installed in pressure tanks, have two operating points known as the cut-in, the reset point, or the cut-out, the trip point. The cut-in point is for the falling pressure and the cut-out point is for the rising pressure. Every switch also includes a differential or range based on the cut-in and cut-out points. Both the cut-in and cut-out on most switches can be adjusted if certain applications require that. For example, if the cut-in is at 40 psi and the cut-out is 60 psi, the differential is 20 psi. When I talk about differential, it means that is now the normal or the average pressure that you would want to come out of your faucets. The other item is called the float switch. A float switch detects the level of a liquid in a tank or container. Usually this is now installed on gravity tanks. It floats on top of the liquid surface and acts as a mechanical switch as the liquid levels goes up or down. They control devices like pumps, valves, or alarms to notify users. They are cost-effective, reliable, and can be used with a wide variety of liquids. Now, how do you compute for your water tank size? Based on the volume of water requirement as per the International Standards Code, 135 liters is needed for daily use per person per day. Breakup is down below. So, for a water tank size and capacity calculations, let's say for a typical family of 4 members, the total water requirement is 135 liters times 4 will get you 540 liters per day or 16,200 liters per month. Now we all know the volume of water formula as 1 cubic meter is equivalent to 1,000 liters of water. So meaning to say, if you were to compute for a water tank, let's just say you are computing for a water tank with the volume size of 1 cubic meter, you will be getting 1,000 liters of water to fill up that tank. Now these are the certain formulas if you would like to compute for your water tank size. As you can see, you have the horizontal cylinder tank and the vertical cylinder tank. This one is for the rectangular tank or rectangle tank, then the horizontal oval tank. There was a horizontal oval tank based on the previous slide. This one here shows the vertical oval tank. And down below is the horizontal capsule tank. This one shows the vertical capsule tank and the horizontal 2:1 elliptical tank. And the last one is the horizontal dish ends. Now, I've shown you the different forms of tanks. It is now up to you to decide what type of tank would you like to use or buy. Then from there, you can use the computation there to start computing for the size of the tank that you are requiring. Now let's go to pump. A pump is a device that moves fluids, liquids or gases, or sometimes slurries, by mechanical action, typically converted from electrical energy into hydraulic energy. So, if we look at the last paragraph, a water pump is a mechanical device that can circulate water or raise it from one level to another. How does the water pump work? Water pumps draw existing water into the pump by suction through an inlet point. The inlet point has a lower rate of pressure than the outlet point. Now let's talk about the different types of pumps. The first is what is called as a direct lift. Usually this is what is found in deep well water sources or groundwater sources. It's a fixed quantity of water is physically raised in a single or a number of containers. The next is what is called as a positive displacement pump, which will deliver a constant amount of discharge, no matter what the discharge pressure is, and must not run against a closed valve on the discharge side, meaning to say, when this pump turns on, there should not be any type of resistance on the out portion or the outside portion where water is flowing out. Now, another type of pump is what is called as a positive displacement, which lift a given volume of, let's say, water for each cycle of operation. It can be divided into two main classes, which is called the reciprocating and rotary. Reciprocating pumps include piston, plunger, and diaphragm types. Rotary pumps include gear, lobe, screw, vane, and cam pumps. The next is what is called as an inline pump. It is a centrifugal pump whose pump discharge and pump suction nozzle lie in a straight line of piping, meaning to say the inlet and the outlet flows into one straight line. The next one is what is called a submersible or sump pump. A submersible pump is a device which has a hermetically sealed motor close coupled to the pump body. The whole assembly now is submerged to the fluid to be pumped. The main advantage of this type of pump is that it prevents pump cavitation, a problem associated with the high elevation difference between pump and the fluid surface. The submersible pump pushes fluid to the surface as opposed to jet pumps, which create a vacuum and rely upon atmospheric pressure. These submersible pumps is usually found in underground cistern tanks or underground water tanks. And the last type of pump is known as the gravity pump, or what is commonly used, or the term used is called as a ram pump. It works by using the potential energy of water at a higher level than the pump. The water flows down a pipe to the pump, and its kinetic energy of the pump itself is used to pump up a fraction of that water volume to a height that can be several times the height of the original water source. This is not magic energy or perpetual motion. The majority of the water flows downhill to waste, but the kinetic energy of the water is enough to pump a small fraction of it to a high level. In other words, it is quite inefficient if there is a natural source of water that would ordinarily just flow away. It affords an essentially zero-cost method of having a supply of water at a high location. Click the subscribe button to discover all the other videos in this site. Click the notification bell to be notified about new videos that we post. If you have additional comments, please post them down below. or at our Arkida Facebook page, and I will answer all your queries. Thank you.